we're going to simplify an absolute value that has a complex number. So this first part of this slide, in this box, I just pulled it from your textbook. I thought the example looked pretty nice. I'd say you probably don't need to write it down. This is the definition here. An absolute value of a complex number, so complex number is a plus bi, is a distance from its origin. So here's my origin, 0, 0. In the complex plane, it's denoted as a plus bi. So there's some point over here, 3 plus 4i. You want to find out what is the distance in the red here. So you're going to take 3 units and square it. And then you're going to take 4 units and square it. And then square root it and add them together, and you get 5. The square root of 25 here is 5. So this distance is 5 units. So that's how you can find the absolute value of a complex number. What you're going to see more is like what I have here in the slide on example A. They're going to give you something like this. 3 plus 5i. What is the absolute value? So you square the real part. You square the imaginary. Don't worry about the I. And then you simplify it. So let's do that together. So 3 times 3 is 9. 5 times 5 is 25. And then you would add those two numbers together. And then see if you can simplify it. Square root of 34, you can't simplify, you can't break down that radical anymore, so you're done. So that's the absolute value of that complex number. Second example, find the absolute value of negative 7i. That's a complex number. If you rewrite it as 0 minus 7i, this is your real part, and there's your imaginary part. If I use that absolute value technique that I did in this previous example, it's going to be 0 squared plus 7 squared, or negative 7 squared. Now we simplify that. 0 times 0 is 0. Negative 7 times negative 7 is 49. Add those two numbers together. You get the square root of 49. And the square root of 49 is 7. If you don't know that, rewrite it as 7 squared. Index is 2. And you get 7. So the absolute value of negative 7i is 7.